Hey guys, so today we're going to start a new unit, and it is on polynomials. And today we're going to talk about the difference in monomials and polynomials, and we're going to talk about how to classify polynomials. So the first thing we're going to talk about is what monomials are. A monomial is a number, a variable, or a product of numbers and variables. So the key is there is no addition and subtraction in a monomial. So some examples of monomials: it can be a number, so it could just be 4. It can be a variable, so it could just be x. Or it could be a product of numbers and variables. So it could be 7x, it could be 3x squared, or it can be 73x squared y cubed, because that's still just a product of numbers and variables. Okay? And when we have monomials, we are going to use exponent rules to simplify monomial expressions. What are exponent rules? Well, I'm going to tell you. So the product rule says that whenever you have a to the m power times a to the n power, so they have to have the same base, but they can have the same or different exponents, you add those two powers together. Okay, and so what that looks like as an example would be x squared plus x to the 7th equals x to the 9th, because 2 plus 7 is 9. So, and these are just things you're going to have to memorize and learn to work with over time, okay? And I can show you a little bit, so the reason that this power rule works, x squared, I just realized that I put addition in there. That is incorrect. This should be times. Okay. So x squared times x to the 7th. X squared is just 2 x's times each other. Then we're multiplying that by 7 more x's. So if we multiply those together, we now have 9 x's, and so that's x to the 9th. So if you ever need to work these out because you can't remember them, there is a way to logically figure out these exponent rules. The power rule, this is when you have a power to a power. So if we have a to the m power raised to the n power, we multiply those powers together. So in this case, it would be, if we had x squared to the 7th power, that would be x to the 14th. And that works because we would have x squared times itself 7 times, and so we have x times x times x times x times x times x, x times x, x times x, 1, 2, 3, 4, 5, 6, and 7. And if we multiply all those together, there are 14 x's, and that is 14, or x to the 14th power. The quotient rule tells us that a to the m power over a to the n power equals a to the m minus n power. You subtract them whenever you divide. So if we had x to the 7th over x squared, that would equal x to the 5th. And I think it's easier to look at this as like a fraction and look at things canceling. So we have 7 x's on top and we have 2 x's on the bottom. Well, we know that anything over itself is 1, so we can cancel out 1x here, 1x here. We can cancel out an x here and an x here, and now we're just left with x to the 5th. And now we have the negative exponent rule. This says that a to the negative m power is equal to 1 over a to the positive m power. And I also want to show you this as when you do fractions, because if you have a over b to the negative m power, that is equal to b over a to the positive m power. So if you have a fraction that's to a negative exponent, you flip that fraction. And I think that's important to remember as well. So if we had x to the negative second power, that equals 1 over x squared. And then if we had x over y to the negative second power, that equals y over x squared. And finally, the zero exponent rule. This says that a to the 0 power is always equal to 1. The only number this is not true for is 0. 0 to the 0 power is undefined. But everything else to the 0 power is equal to 1, and that is just a rule that you have to remember. So even if we have 7x squared to the 0 power, that still equals 1. If we have 437, 3, 6, 4, 2, those are not even numbers anymore, and we take that to the 0 power, it's still just 1. So kind of like anything, if you multiply anything by 0, it's 0. It's the same kind of rule. If you take anything to the 0 power, it's always equal to 1. And then at the bottom, it says here that when we add or subtract monomials, we should combine like terms. So what are like terms? I want you to write this in the box that's on the side of your paper under the word examples. Like, I guess it's not a box by itself, but in that empty space under the word examples, write these notes down. So terms are separated by addition and subtraction. And like terms must have exactly the same variables with exactly the same exponents. So x squared and 2x squared, those are like terms. But x squared and x to the third, those are not like terms. All right, when combining like terms, you add or subtract the coefficients, so the number in front of the variable, and keep the variables and exponents the same. And we're going to practice this some. Our first example comes from number 1, and this is just multiplication. So when we multiply monomials, we multiply the coefficients. So 5 times negative 7 is negative 35. And then we multiply the variables, the like variables. So x squared times x to the 6th. If we look back at our product rules, we know we should add the two exponents. This will give us x to the 8th. And then that's all you have to do. That's your answer. Some of this may seem like a review to you, but I want to make sure that we've refreshed our memories because this is going to be important to the next steps that we take. So number 2 looks a little bit different. The first thing that we need to do is apply this exponent to everything inside of here. And so when we square something, that means that we multiply it by itself twice. So I'm going to write it twice. And then multiply those, which we still have our 8ab to the 9th on the end. So again, when we multiply monomials, we take each little piece and multiply it together. So negative 2 times negative 2 is positive 4. A cubed times a cubed is a to the 6th because we add those. And b times b is b squared. And then we need to multiply that by 8ab to the 9th. So 4 times 8 is 32. A to the 6th times a is a to the 7th. And b squared times b to the 9th is b to the 11th power. Let's look at number 3. It's got some quotients on it, some division. The first thing we want to do is simplify this fraction. So again, we're just kind of taking it piece by piece. 54 divided by 3 is 18. m to the 6th divided by m squared. Remember, we subtract the exponents. That's going to give us m to the 4th. And then n to the 4th divided by n. Anytime there's no exponent, we assume it's a 1. It is understood to be 1. So 4 minus 1 is 3, so that means we have n cubed. And then we have minus 10m to the 4th n cubed. So now we have to question ourselves. We have addition and subtraction now, and we agreed earlier that terms are things that are separated by addition and subtraction. And then we said that like terms have the exact same variables with the exact same exponents. So we have m to the 4th and m to the 4th and n to the 3rd and n to the 3rd. These two terms have the exact same variables with the exact same coefficients, or exact same exponents. That's the word I'm looking for. So we are going to subtract the coefficients, or add them together, whatever you want to call it. 18 minus 10 is 8. And then you keep this the same. You don't change the variables when you add and subtract. If you think about it, so sometimes when I'm thinking about variables, I like to think about actual objects. Like if I had 18, like say that this represented apples. If I had 18 apples and I took away 10 apples, I would still have 8 apples. I wouldn't have 8 oranges. Like we don't change the thing that we're measuring. So anyway, your answer is 8m to the 4th n to the 3rd. This is the last example I'm going to do on this worksheet, or on this section of the worksheet. So this is just multiplication. So we are going to multiply the coefficients. 2 times 10 is 20. And then k to the 4th times k to the negative 7th. Remember, we add exponents whenever we are multiplying. So 4 plus negative 7 is negative 3. So we have k to the negative 3rd. However, you cannot leave something with a negative exponent. That is not simplified. When you have a negative exponent, if you remember, a to the negative m equals 1 over a to the m. So what we're going to do is we're going to take this and we're going to move it into the denominator. And we can do that because, so this really means 2 times 1 over k cubed. And 20 would be understood to be over 1. So if we multiply these together, we get 20 over k cubed. Or you can just recognize that this is what's going to happen, and you can say, okay, I just need to put this under the 20 and make it positive. So your answer is 20 over k cubed. Now that we've talked a little bit about monomials and practiced a little bit with them, we're going to talk about polynomials. And polynomials are the sum or difference of many monomials. So this is when we add and subtract monomials from each other. And the highest exponent of a polynomial is called the degree. So this is just like a vocab word that you need to remember. The degree of a polynomial is the highest exponent that exists in that polynomial. In standard form of a polynomial is to always write the largest, or no, the exponents in descending order. So start with the biggest exponent and go down. Now, I want you to put a couple extra notes here, and most likely you're going to want to write them on the left under the word polynomials. And what those say are, use the letter, so if you have multiple variables in the same polynomial, so with multiple variables, use the variable that comes first in the alphabet to order your polynomial. So if you have A's and B's in your polynomial, you use the A's to choose the order. And we're going to do an example of that, so don't get too confused. But then the other rule is that the constant, the number that has no variables, is always last. All right, so standard form of a polynomial. We want to write this in standard form. The way that I go about this is the first thing I do is I put a line in to the left of every addition or subtraction so that I make sure whenever I pick these up and move them around, I keep the correct signs with them. So the next thing that I want to look at is we have two variables, but we're going to use the variable that comes first alphabetically to order these. So we don't even care about the B's when we're choosing the order to write this in. We only care about the A's. So this is a squared. This is a to the first. There's no a here. So that would be like saying a to the 0 because anything to the 0 power equals 1. So if we had a to the 0 power, it would just be 1 and that would be it. And then this one is a to the third. So we want to put these in descending order. So biggest goes first. So that's a positive 4a cubed. And then the next one is squared. So that's a positive 18a squared b squared. And then we have a 1. So that's a positive 7ab. And then no a's in this one, negative b squared. So we have 4a cubed plus 18a squared b squared plus 7ab minus b squared. And that is in standard form. And the final thing that we're going to talk about is how to classify polynomials. And polynomials are classified by degree and number of terms. So we said that degree is the highest exponent in a polynomial. So that's the biggest exponent in the whole thing. And the number of terms, remember terms are separated by addition and subtraction. Okay, all right, and these have names. So when we name a polynomial, when we classify a polynomial, we give it two names. The first name is based on the degree, and the last name is based on the terms. And so you need to remember that because we're basically going to name polynomials. We're giving them a first name and we're giving them a last name. So the first name that goes with each degree, so if we have a 0, if we have something to the 0 power, remember it just equals 1, so that polynomial would just have numbers in it. It wouldn't have any variables. And this is called a constant function. If the highest exponent is 1, it is linear because the graph of that kind of function would look like a line. If the highest exponent is a 2, it's called quadratic. That's what we just did a whole unit on. Those are parabolas. If the degree is 3, if the highest exponent is a 3, it's called cubic. If it's a 4, it's called quartic. And with this one, I like to think of like there's 4 quarts in a gallon. That's how I remember that word. And then if there are 5, it's quintic. And I remember this one because if you have 5 babies, like 5 twins, they're not called twins, they're called quintuplets. And quintuplets is how I remember quintic. All right, then for the last name, the number of terms. This is where if we have one term, it's called a monomial. If we have 2 terms, it's called a binomial. Bi means 2. Bicycle has 2 wheels. 3 terms is a trinomial. Tri means 3. Tricycles have 3 wheels. And 4 plus is called a polynomial. Poly means many. I think of polygons. Polygons have many sides. So let's practice naming a couple of polynomials. All right, so remember that we have to find the degree and we have to find the number of terms. So the degree of this polynomial is 1 because the largest exponent in number 13 in the whole thing, the largest exponent is just a 1. So we have a degree of 1. How many terms are there? Terms are separated by addition and subtraction. So if we draw a line here, we have 1 term, 2 term. There are 2 terms. So the first name that goes with degree of 1 is linear. The last name that applies to 2 terms is a binomial. So this is a linear binomial. That's the type of polynomial this is. Okay, so on number 14, the degree, we want the highest exponent. So we've got a 5, we've got a 4, and we've got a 1. The highest one is a 5. So that makes the degree 5. And the number of terms, we separate it at every addition and subtraction. And we've got 1, 2, 3 terms. So there are 3 terms here. The word for a degree of 5 is quintic, quintuplets. The word for 3 terms is trinomial because bicycles have 3 tricycles have 3 wheels. And so this one is called a quintic trinomial. And I think that you guys are going to grasp that pretty quickly. I don't think you're going to struggle too bad. So I'm going to let you all finish the rest of this worksheet. Thanks for listening. I hope that you have a wonderful long weekend, which is probably already past if you're listening to this. But I will see you guys soon. Bye.